Internet, good morning. Today I want to go ahead and discuss 7-1 ratios, proportions, and radicals. So starting off with a ratio, which is just a fancy word for rate. It is basically a comparison of two quantities using division, and we can express that as A to B or A colon B or A divided by B, where B cannot be 0. And the reason why B cannot be 0 is because you cannot divide by 0. That will give you an undefined. So examples of ratios are 1 to 2, you probably have heard that before, or 35 miles per kilometer, 35 miles per hour, which is a ratio. Or you can say 3 eggs for every cake that you make, or maybe you could say 6 eggs for every 2 cake. What is wrong when I said 6 eggs over 2? Or 6 eggs per cake. Well, 6 over 2, if you take a look at that, this is a fraction. Again, ratios are fractions, right? 6 divided by 2 can be reduced to 3 over 1, which is exactly what I said before, 3 eggs per cake, right? 6 eggs for every 2 cake is the same thing as just saying 3 eggs per cake. And me saying 6 eggs for every 2 cake, that's just redundant. So we want to make sure that our ratios, or specifically our fractions, are reduced. And that's what, math teachers always say, reduce your fractions, right? Anyways, so that is what a ratio is. And now an extended ratio is used to compare 3 or more quantities. So what that means is that you could have a form A to B to C, right? Just like over here, this is just 2 quantities. Now I'm dealing with something involving 3 or maybe more quantities. This is 1 quantity, that's another quantity, that's another quantity, and it can keep going forever and ever with your ratio. So let's go ahead and let's go ahead and take a look at extended ratios in a geometry context. Here I have an example. The ratio of the measures of the angles in a triangle is 3 to 4 to 5. Find the measures of the angles. Okay, so I have a triangle over here. And I'm going to go ahead and put 3, 4, and 5, okay? What's wrong with that? Well, 3, 4, 5, these are my interior angles, but if I add them all together, these are going to give me 12, right? What is wrong with that? Well, if you recall from, back in semester 1, the sum of the interior angles of a triangle is 180, right? This is 12. That's not 180. So we need to go ahead and take a look at the problem again. The ratio of the measures of the angles in a triangle is 3 to 4 to 5. So what do I have to put next to these numbers? Well, I got to put x. So x here, and x here. What do you think I'm going to do now? That's right. I got to go ahead and add all these numbers up, or all these terms up, and set it equal to 180. Right? So let's go ahead and combine the like terms. You should get 12x here, which is equal to 180. And then if I divide both sides by 12, you get x equals 8. Okay? X is equal to 8. Now what do you think I'm going to do now? There you go. You got to plug them in. That's right. You got to do 3 times 8, because we know if I have x is equal to 8, I got to plug them in, right? So 3 times 8, that's going to be what? That's going to give me, wait, what the heck was wrong? Oh, no, this is not 8. Sorry, erase that. That should be x equals 15, my bad. All right, there you go. 3 times 15, which is going to give me 45. And over here, this is going to be what? 4 times 15. Which is 60 degrees. And over here, that's going to be 5 times 15, which is 75. So if you add all these angles together, that should give you 180 degrees, right? Okay, so you're probably wondering, oh, what the heck does this x even mean? Like, what does that even represent, right? So here, this is an extended ratio, right? 45 to 60 to 75. That's A to B to C, right? So let me write that down. 45 to 60 to 75. And what number goes into 45, 60, and 75 at the same time, right? 15. 15 goes into all of these numbers here. Because what x represent, so what does x mean? What x means is that we know that 3x, 4x, and 5x are the angle measures. Right? So x, where x represents what they were reduced by. Just like, sorry, let me give you some time. If you can, please pause and write all this out. So if you recall, we said 6 over 2, right? Reduce your fraction. Well, what number can, what number goes into 6 and 2 at the same time? Well, that's going to be, what's that supposed to 2, right? 2 goes into 6, 2 goes into 2. That should give you 3 over 1. Here, just this, you can treat this like a fraction, but we have 3 quantities. The number that goes into 45, 60, and 75 is 15, because 45 is going to give you, if I divide that by 15, you get 3x. If I divide by 60 here, you get 4x, and 75, that's going to give you 5x, right? So that's what x represents, okay? Anyways, let's go ahead and take a look at another example. The ratio of the length and the width of a rectangle is 5 to 2. The perimeter of the rectangle is 112. Find the measure of each side. So one thing I want to go ahead and note is, what is a perimeter? Perimeter means the distance around a figure, right? You're probably used to hearing perimeter as just add up all the sides, which is absolutely true, right? You have to add up all the sides. The formal definition of perimeter is that, let's say that you have a figure right here. Pretend that this is like a little garden of yours, and you want to go ahead and walk around the garden. So what is the total distance of you walking around the garden, right? So I'm adding up all the sides here. So the formula, since this is a rectangle, the formula for the perimeter of a rectangle is 2 times the length plus 2 times the width. That's just the short way of just adding up all the sides of a rectangle. So we know that the ratio of the length and the width of a rectangle is 5 to 2. So what do you put here and here? Well, it's just the same case with what we did over here, right? We put the numbers, 5, which is my length, and 2 here, and then right next to it we should just put the variable x. Okay, so let us set up our equation. It says we need to find the perimeter. We know the perimeter is equal to 112 over here, so that's going to be what? So I put that in using my formula. 2 times 5x plus 2 times 2x, which is equal to 112. So I'm going to simplify this. I get 10x plus 4x, which is equal to 112. And then I'm not done, so I combine these two terms here. 14x is equal to 112. And then I divide both sides by 14. I get x equals 8. And then I am not done, right? Because I have x is equal to 8. I got to plug it into my, I got to plug it into these little sides here. So I get what? 5 times 8, which is, 5 times 8, which is 40. And then over here, this is 2 times 8, and that is 16. Okay, so what does this all mean? The length of this rectangle is 40 degrees, and the width of this rectangle is 16. And you're done, because it's just asking you to find the measure of each side. Okay, now if it asks you to find each side and then figure out the area, all you got to do is length times width. You multiply this number by this number. Okay. So take a minute, pause if you need to, and then finish copying, and then let's go ahead and move on. Okay. All right. Now, we've already talked about ratios before, right? A ratio is 2 quantities, A to B, right? You probably have heard of the word proportion, and maybe you have heard of something called the butterfly method or the cross product, okay? So let me go ahead and just tell you what a proportion is. A proportion is an equation where 2 ratios are equal, right? So that whole cake example, I said, let's say 3 eggs per cake, right? So what if I say 6 over 2 is equal to 3 over 1? Is this true? Is the left-hand side equal to the right-hand side? Yes, right? This is a ratio A to B, and this is also a ratio A to B. You can set them equal to each other, and if they are equal to each other and they are true, that means that they are proportional. Okay? So we're gonna go ahead and look at these fancy words. I don't really think what these mean. I don't care about these, but it's just good to know because I think we're going to go ahead and talk about something called the geometric mean later on. So here we have two ratios. They are equal to each other, right? The reds are the extremes and the blues are the means. So what we say here, so let's go ahead and write that down first. So we say A to B, which is equal to C to D, right? A to B is equal to C to D, and I represent those as colons. And then the A and the D, these are what we call the extremes. And then over here, the means are B and C, okay? Again, you don't really need to know what extremes and means. Like, you don't actually have to know the word. You already know how to do it, which, that's totally fine. So the cross product basically is the product of the means is equal to the product of the extremes. So what I have to do is I use something called the butterfly method. I multiply the B and C together, set that equal to the A and D. Okay, so let's go ahead and do some examples. Over here, I have 6 over x is equal to 21 over 31.5. Use the butterfly method. I multiply these two numbers here. I get, 6 times 31.5, and then you draw an equal sign there. And then you're going to multiply these two numbers here, 21 times x. And then let's go ahead and simplify. I have my notes here to figure out what the heck 6 times 31.5 is. That's going to be 189 equal 21x. And then good, I'm going to solve for x. 9 is equal to x. This is my answer. I only need to figure out what x is equal to, okay? And that's how you do it. All you got to do is you're going to use the butterfly method, and this is something that we're going to be using pretty much the rest of the semester. We're going to be solving proportions for the rest of the semester, so it's really, really good, and this is the time now to review how to solve proportions. Okay, over here, I have x plus 3 over 2, which is equal to 4x over 5. Let's go ahead and use the butterfly method. So here you have 5 times the quantity x plus 3, and it's very, very important that you put the parentheses because you have to use the distributive property there. And we set that equal to 4x times 2. And then distribute 5x plus 15, which is equal to 8x. And then I'm going to subtract both sides by 5x here. So I have 15 equals 3x. And then what is this? 5 equals x. This is my answer. Okay? Now, students would say, well, if I'm going to use the butterfly method here, I will just do 5 times x plus 3. And that is Thank you. And that is absolutely incorrect because you need to make sure that you put the parentheses there because this x plus 3 represents one number, right? If I say 2 plus 2, that is one number because 2 plus 2 is 4. 4 is one number. So make sure to put the parentheses there. That's very, very important because that is one quantity. That is one object there, okay? All right, good. Let's go ahead and move on to the next one. If I'm going too fast, make sure to pause and then proceed to the next one. All right, here 4 times x. And here I get what? 6x plus 30, right? I skipped a step there because I know I'm going to use the distributive property. So 6 times x plus 6 times 5, which is 30. Hence, I have that over here. Then I'm going to go ahead and subtract both sides by 6x. I get negative 2x, which is equal to 30. And therefore, you get x is equal to negative 15. And this is my answer, and that's all I have to do, okay? There you go. That's me using the butterfly method for these 3 problems. Okay? Alrighty. Hopefully you're writing all of this down and understanding how to solve proportions now. Okay, let's go ahead and take a look at something different. We're going to go ahead and talk about radicals. Okay, a perfect square is the product when a number is multiplied by itself, right? So for instance, I have x times x, right? They are the same number. That's going to give you x squared, right? A number times itself, it's just going to give you something squared. If I go into something more specific, 5 times 5 is the same thing as saying 5 squared, and 5 times 5 or 5 squared is going to give you 25, right? And 25 is a perfect square because this is what a perfect square is. Like if I say 2 times 2, right? 2 times 2 is the same thing as saying 2 squared. So if I draw my rows and columns, well, here I have 2 over here and 2 over here. Well, what's 2 times 2? 1, 2, 3, 4. And look at that. That forms a perfect square, even though it doesn't look like I draw a perfect square. But yes, that's why it's called a perfect square, okay? So it's very, very important that you know your tables of perfect squares, right? 1 times 1 is going to give you 1. 4 times 4 is 16. 11 times 11 is 121. 12 times 12 is 144. And 20 times 20 is 400, right? It's very, very important that you know if your perfect squares from 1 to 20 because this is going to help you with simplifying radicals, okay? Now, we're done talking about perfect squares. Let's go ahead and talk about square roots. A square root is a value that when you're multiplied by itself, it gives the original number, right? So the thing that you've been doing in Algebra 1, you know that the inverse operations for solving for x, right? You know that the opposite of addition is subtraction, and the opposite of division is multiplication, right? And vice versa and such. What I want you to understand is that the square root and some value being squared, this little floating 2, the exponent, these things, they don't like each other. And therefore, you get the lonely x. The x is being freed from everything here. It's by itself. Here, the square root of 25, which can be rewritten as the square root of 5 squared, right? 5 squared is 25. The square root and the 2, they do not like each other. So therefore, the 5 is free. Okay? So that's something that you need to know about square roots. So let's go ahead and take a look at this method over here. It says method 1, simplifying radical. And again, this is just review, right? Everything is, or mostly everything here is review. Method 1 says, look for the largest perfect square factor. Divide the radicand. And what the radicand is, it's just the number under the square root, by the perfect squares smaller than it until you find one that is a factor. Then take the square root of the perfect square and leave the other factor on the radical. Now what that means is that I take a look at this number here and I'm going to use one factor that has a perfect square and I multiply that by something that'll give me 25 or 75, right? So let's think about what two numbers multiply together that will give me 75, where one of them has to be a perfect square. Well, I'm thinking 25 because 25 is a perfect square. Just like so, and right here. And if I multiply that by 3, well, what is that going to be? Well, what's 25 plus 3? Well, that's going to be 75, and you know that because you've been working with quarters, right? 3 quarters is 75 cents. So the square root of 25 times 3, you can rewrite that as the square root of 25 times the square root of 3. Okay? Oh, look at that. What is the square root of 25? Well, over here we know it's just 5, right? So what happens here is that if you have, if you can take the square root of something and then figure out what the number is, then you put it outside of the radical sign. So since we know that the square root of 25 is 5, we put it outside of the radical sign, and then what's left is going to be inside the radical. And this is your answer, okay? So take a minute, pause, reflect. And if you have any questions, let us know, and then we'll address the questions later on. Okay, let's go ahead and take a look at method 2. It says use a factor tree and look for pairs of factors. Now, you probably have heard of the buddy system, maybe, depending on your teacher. Basically, you break down a number into its factors. Circle each pair of numbers and underline any numbers that do not have a pair. For each pair, bring out one of the numbers and multiply it with any other factors that come out. Then multiply all the underlined numbers back together and the product will remain under the radical. So basically, you don't So here you can, when you're using the factor tree method, you don't have to think about you don't have to think about perfect squares, right? So I'm going to think of two numbers that multiply together to give me 128. And you can do it however you want. You can try to make your life easier by thinking of a perfect square. It's totally up to you, but all you're doing is you're just finding buddies. So the square root of 128, I'm thinking of two numbers that multiply together to give me 128. I'm thinking 64 and 2. So because 64 times 2 is 128. Now over here, I'm going to think, okay, can I break down this 2? I mean, you could try, well, but what are the two numbers that multiply together to give me 2? Just 2 and 1, right? But here's the thing. I'm still left with a 2 right after that. And that's something that I don't want to do, because if I keep breaking it down, I'm going to have this, and I don't want this. So this right here is what we call a prime number. Basically, it's I can't break it down even further. The two numbers that multiply together to give me 2 is just 2 and 1, right? Or a prime number is a number that's multiplied by 1 and itself. Here, the 64, I'm thinking of two numbers that multiply together to give me 64, and I'm thinking 8 and 8, right? 8 and 8. And there you go. So look at that. Here's why it's called the buddy system. And the reason why it's called the buddy system is because I have a pair of the same number. And what you do is that you get rid of one of the numbers and you take it out of the square root. Okay, and it's going to go outside. So let's go ahead and do that. I draw my square root, take one of the 8s out from the pairs, put it outside of the radical sign, and then what do I put inside the radical, right? So the lonely numbers, if I can't break down a number, it's going to go under the square root. So the 2 is going to go under the square root, and then I'm done. This is my answer. This is already simplified. I can't break anything down. I can't break this down any further, okay? So there you go. That's the buddy system working. All right, let's go ahead. Oops, I did not erase that. But let's go ahead and let's do this problem, and then we're done. So the square root of 50. I can go ahead and think of two numbers. I'm thinking 25 and 2. And over here, I can break down the 25, which is 5 and 5. And look at that. I see a pair of numbers. That means I get rid of one and then take the other 5 out. So that's going to go outside of the square root. And then the lonely number is going to go in the radical sign, or under the radical sign, and that's my answer. Okay? Good. There you go. Okay. Make sure to pause if I am going way too fast. Write that down. Okay. Let's go ahead and take a look at this one over here, because this one's different. The reason why it's different is because the 5 is already outside of the radical sign. So what happens here is that anything that comes out of this 84, anything that comes out of the radical sign, it needs to be multiplied by this number. So here I have 84, and I'm thinking two numbers. I'm thinking 4 and 21. I can go ahead and break down the 4, but I know that if I do let's just go ahead and break down the 4. I have 2 and 2, and then that's a pair. I'm going to eliminate the 2, and it's going to go outside of the radical, and it's going to be with the 5. So I have 5 times the 2, which is the square root of, okay, let's go ahead and break down the 21. 7 and 3. Oh, no. If I break down the 7... I can't. I get only 7 and 1. If I break down the 3, well, I can't, because I get 3 and 1. And that's going to be, an infinite issue. So 21, or I could put these number on the radical sign. So if I have the lonely ones that are prime numbers, all I have to do is I put 7 times 3. Okay? The lonely ones need to be multiplied under the radical sign. Then I can go ahead and simplify. 5 times 2 is 10 root, 21. This is your answer, and I am done. Thank you for watching. I will see you in the next video. Make sure to like, comment, subscribe. There you go. Did you hear that, Rivers? All right. Bye-bye.